Hi, welcome to rule of acquisition number 19. This is known collectively as the Sentiency tell. And the rule of acquisition 19 proper is theories which require objects to think for themselves are gibberish. And rule of acquisition 19a, objects do not act on observations, they react to applied forces. Okay, there are scientific models, we call them laws, in which an object is required to observe its surroundings and choose what to do. Well, this indicates sentiency on the part of the acting object. It will be demonstrated here that these kinds of models or laws derive their sentiency from us, the observer, and mask the effect that we have no clue what causes the effect to be true. Now let me give you People's Exhibit A, Lenz's Law. If we look at the Wikipedia definition, states that the current induced in a circuit due to a change, and they had other stuff that are removed, in a magnetic field is so directed to oppose a change in flux and some other stuff which I removed. You didn't need the other things. That was just another case put in there. But who or what is the director? Who makes the decision to oppose? Let's be clear. Lenz's Law does in fact give good answers and is therefore certainly useful. Okay, the tell. Here's where the tell is. It's required that the coil or currents in the coil act to oppose the applied magnetic field. A proper theory or model should explain how the change in magnetic field pushes the charges around. How the charges react to the applied magnetic field. We need to find, the theories have to be reactions, not actions. Okay, charges should react to the applied field, not act to the opposed field. This indicates that the charges can observe and act accordingly and think for themselves. And doesn't this imply that opposing a field requires expenditure of energy? Let me give you an analogy. Okay, suppose you have a ship on the sea where a tidal wave is approaching. Well, if the ship is abandoned and there's no crew to take any action, the ship will certainly react to the tidal wave. And it will react the same way. If this is Groundhog Day and you played it over and over and over again, that ship will react the same way every time. On the other hand, if you have a ship that's crewed, that crew is going to observe the approach of the tidal wave, if they know what they're doing, and act to oppose or mitigate the damage. Okay, this requires positioning and configuring the ship for the ideal outcome. In other words, battening down the hatches, starting the motors, getting some velocity to head toward the tidal wave if that's the course of action chosen. And this requires action before the wave hits. And the action may be different depending on the surroundings. If you're already in a sheltered harbor, you're just going to batten down and wait it out. If you're out in shallow water, you're going to head for deep water. If you're out on the high seas, you might decide the best thing to do is head straight into the tidal wave, maybe even at a little angle depending on how your ship is balanced. Okay, so there could be very many different courses of action taken, maybe even wrong courses of action taken. Okay, so to act is to make a conscious decision on what to do. And usually if you're going to start positioning the ship, you're going to burn fuel to oppose. Instead of this ship, this isn't going to require fuel, it's just going to be taken by the wave. And whatever's going to happen is going to happen. The energy of the wave is going to cause what's going to happen. Here, this thing has to burn fuel to position itself. Sailors who are burning calories have to get up and batten down the hatches and pull in the thing and drop there, whatever they're going to do. Requires the expenditure of fuel. Now let's look at Lenz's Law. We'll go back to Lenz's Law now that I've filled you up with the difference between reaction and action. Suppose you had a changing magnetic field. That's the blue crosses. It's changing, it's going down into the page. And you have a loop of copper here. Well, according to Lenz's Law, the loop or the charges are going to act to oppose the magnetic field entering the loop, which means that if we just look at this here, the current is going to go counterclockwise because using the right-hand rule, a current in this direction will come up inside the loop, which will oppose the changing magnetic field going into the loop. Fine. But what if you flip the loop over? So now this same piece of wire is still here. Its position and orientation in the universe haven't changed, except now that the rest of the loop is on the other side. Well, we know Lenz's Law is going to work, but how? How do these charges here know that, oh, now we're supposed to go this way instead of this way? How do they act? How do they observe what's going on? How do they decide what they're going to do? That makes no sense to me whatsoever. And let's suppose we were to prevent you, the observer, from seeing which side the rest of the loop goes. Well, how do you know which way the charges are going to go? You don't. And so you can't apply Lenz's law because you can't see it. This loop is still going to react the way it's going to react, but you can't tell which way it's going to react. And therefore, the problem is the law. The law requires you to make the decision. You supply the sentiency to the law. And you're doing this because of what we've seen previously. And so without the knowledge of the rest of the loop, you can't apply Lenz's law. You can't know what's going to happen. And that's where the problem is. You are supplying the sentiency. Charges cannot make the observation about the distant surroundings in order to choose a course of action, but you can. This indicates that we don't know the means of coupling between the magnetic field and the charges. Okay, rule of acquisition 19a. Objects do not act on observations. They react to applied stimulus, just like the tidal wave hitting the ship. Now, if we remove the wire altogether, we have to say to ourselves, without the wire, let's say we have no wire, we just have a plain charge sitting there. Well, we know that if the charges are the building blocks for electromagnetic theory, then electromagnetic theory must explain how a changing magnetic field couples to a lone electron, regardless of any wire construct that it's part of. How does a lone electron act to oppose a changing magnetic field? It can't. If your changing magnetic field has to act on the electron, not the other way around. So lone charges do react. The problem is that the B field abstraction of classical theory does not contain the fidelity to model the complexity of a magnetic field. New electromagnetism solves this problem by eliminating the abstraction. And in new electromagnetism, a magnetic field is a spherical phenomenon, not the toroidal shape as you see in the Biats of art. And by computing the charge-to-charge effects between charges generating the field, because that changing magnetic field is generated by causing other charges to behave a certain way. It's not a manifestation that happens by itself. It's caused by other charges behaving a certain way. And when you consider the behavior of the other charges and couple those behavior of those other charges to the target charge, you can determine very deterministically what's going to happen to that charge. Okay, the problem is that the magnetic field model we're using is an abstraction which constrains our ability to know how it's truly generated. And it's missing information. That's why we come up with the ambiguity that can only be solved by our sentiency in knowing what's happened before is going to happen again. But if you had a charge by itself, you could not know how that charge is going to react to the magnetic field. So, rule of acquisition 19. The sentiency tell, theories which require objects to think for themselves are gibberish. Objects do not act on observations. They react to applied stimulus. In quantum mechanics or other examples where particles will act in such a way to move toward the lowest energy state. Again, this is, I believe, in quantum mechanics they call that action. I believe that's what they call it. Sorry, that just means we don't know what causes them to go to the lower energy state. So wrap up. Sentiency in a scientific model is essentially replacing causality with your brain. You, the observer, based on previous observations, are choosing what the particle will do. This is monkey see, monkey do at its finest. This is a clear indication that causal coupling between the applied action, in our example, the magnetic field, and the reaction, the way the charges move, is unknown. And this indicates an opportunity for research and discovery. Thank you very much. No more voodoo physics that require sentiency on the part of charges.